Hey everyone, today we're going to be building a COVID-19 research bot. It's going to be able to answer COVID and COVID-related questions using the latest research from 2023 and onward. I'm going to show you how to use a vector store and do semantic search on documents, and we're going to learn all kinds of cool stuff, so stick around. If you go to ChatGPT and ask it a question like, how many people died from COVID-19, you'll get a lackluster answer similar to this. It'll tell you that it's only trained on data up through September 2021, and it only has records up until that date. So I wanted to solve this problem by building a research bot that has access to the latest information about the disease by looking up the most relevant scientific research. Here are a couple of the research questions that I wanted to answer. How many people died and were infected by COVID-19? What were the financial implications of the pandemic? What are the best treatments for COVID-19? I wanted to learn about how children's learning was affected by the pandemic. I also want to take a look at things like, long-term COVID, what are the symptoms and what are the best treatments? So these are just a couple of the questions that I wanted to answer. The sources for my data were highly cited articles from reputable sources like the publication Nature, and I also grabbed data from Wikipedia as well. Today we're going to use a new tool called LangChain. LangChain is a very popular framework for prompt engineering and interacting with LLMs. You can do all kinds of crazy stuff with it, and I encourage you to check out the website and look at some of the modules that they provide. Let's take a look at our architecture. We're going to ingest PDFs of the latest research on COVID-19. We're also going to scrape data from different research websites and Wikipedia. I tried using different LangChain tools to ingest that information, but in practice, those tools had a hard time dealing with the large amounts of data. So I used a script to convert those websites, take the HTML and convert them to PDFs, and just ingested PDFs in the end. After that, we're going to do some data cleansing and create data splits, also known as chunking. We're going to store our documents in a vector store, and we'll be using Pinecone today. When we ask a question, we will send that question to the vector store. It will fetch the most relevant documents for us using semantic search. We'll pass those documents along with our user question to an LLM prompt and do some prompt engineering, then pass that to an LLM, and then we'll get our answer back. And we're going to be using Gradio as our chat interface today. So here's our notebook. I have copied and pasted all of the questions that we want to answer and our data sources and links to the different articles. We'll start off by importing our API keys, and today we're using the OpenAI library and Pinecone. I've created an environment file that stores my environment variables, so my OpenAI API key and my Pinecone API key. And if you're unfamiliar with how to do that, I'll paste a link in the video description on how to create your own environment file. Next, we're going to load some more libraries. We're importing the OpenAI embeddings library. We're going to import the PyPDF loader to load our PDF documents. We're using the recursive character text splitter to split our text, Pinecone for our vector store, and a library called TextWrap just to display some of the answers in a more user-friendly way. In the next section, we're loading our research papers, and I'm using the PyPDF loader to just load each PDF one by one here. Now, think about if you had hundreds of thousands or maybe millions of documents. How would you productize that and ingest that and maintain that over time? What would the architecture look like? I think that's a good thought exercise for you to do. After that, we're going to clean up our data a little bit. So here I am manually removing the cover page and the references, just cropping the documents a little bit. We could also use regex to do this if we wanted to automate this process. Next, we'll load our data from Wikipedia. I tried using the LangChain Wikipedia tool, but it could not handle the large COVID-19 Wikipedia page. So it's actually easier just to convert that one to a PDF using a script and then ingest it as a PDF. Next, we're going to create our data chunks. So why do we want to split our documents? Well, two reasons really. Number one, we only want to send relevant information to our LLMs, right? We don't want to send it all kinds of noise and confuse it. And number two, there's a limitation on how much data or how many tokens can you send to your LLM. So we're also operating within that constraint. So the first thing that we do is to set our chunk size. We're setting that to 1500 characters, and we also set how much should our chunks overlap. We've set that to 15%. And then we're using the LangChain recursive character text splitter to create those chunks for us. And we have a couple separators here as well. And we're doing that on all of our documents, followed by adding all of those documents up to one master document called docs. Let's print some information about our documents and see what it looks like. So we have 537 documents of data. We have about 1,400 characters in our first document, so maybe roughly 1,500 characters per document. And overall, we have 685,000 characters in all of the documents. So this is a lot of data that we're going to be working with today. Let's take a look at a sample chunk just to see what it looks like. And here you can see the introduction to one of the research papers. Next, we're going to create embeddings for our data, and we're going to use the OpenAI embeddings to do that. And we're going to follow that up by initializing our vector store. So we have our API key here in our environment, and we're creating an index called COVID-19 bot within Pinecone. Here are some stats about our vector store. So we can see the dimensions of our vector store, 1,536, and we can see the total vector count, which is the number of documents that we're storing there, 537. So that matches the splits that we had. And I'm actually going to delete everything in the vector store so we can populate it again and start fresh. This is just good to do when you're iterating and trying to find the optimal splits on your documents. The next line of code is going to take each document, create an embedding for it, and store it in our vector store. So we'll run this. Okay, so now we've loaded our documents into our vector store. Let's head over to the Pinecone web interface and see what that looks like. Okay, so this is the Pinecone interface. We can see our vector store here, COVID-19 bot. Let's click on it. Here you can see a couple metrics. This is our vector count. You can see when we deleted all of our vectors and loaded them back in there. You can see different API requests here and some latency information and errors. So that's kind of an overview. Everything looks good. We know that our data is in the cloud. Okay, let's try querying our vector store and doing a semantic search. So we'll ask the question, what are the most effective treatments for COVID-19? We'll use the doc search and do a similarity search using this query, and we're going to return 4 documents, and we'll print those out. Okay, so here's an example of the document that it returned. You can see the chunk right here. It looks like it's relevant to the treatment and management of COVID-19. So this is some of the information that we're going to be passing to our LLM later. Let's query those documents that we got back from our vector store. Let's first load a couple libraries from LangChain. We'll use the OpenAI library, the load QA chain. We'll need a prompt template, and we're going to use the load summarize chain here. We're actually not going to be using this one in this example at the moment. And the first thing we'll do is set our LLM. We're using the OpenAI LLM. We'll set the temperature to 0. We don't want a whole lot of variability in the answers at the moment, so we'll just kind of keep that flat. And we are going to use the load QA chain. And the chain type will be stuff, so we're kind of stuffing in those documents that we're retrieving into this chain. Okay, so let's try querying the chain. So let's ask it, how are COVID-19 vaccines accepted in different countries, and what's the acceptance rate in the US? And we'll do a similarity search for that first, and then we are going to pass those documents to our LLM. And this piece of code is just to format the answer to make it a little easier to read. So let's check it out. Okay, and we get the following answer back. It's quite a short answer, maybe a little bit underwhelming. It is correct, but I think we can do better, and that's why we want to introduce a prompt template to get a little more control over the answer. So let's see how we do that. So this is the same code here. We're setting up our LLM. All that's the same. We're using the same question. This time we are going to ask it to return 10 documents for us. So we're going to get a little more information. So this is our prompt template here. So let's check it out. We're saying that you are a helpful AI bot that aids a user in research about COVID-19. You will answer the question. So we're just going to ingest our question here. You'll use a combination of information from the research docs below and the information on the internet. You will answer in a polite and descriptive way, providing sufficient context for the user to understand the answer. Use specifics from the research when possible. Follow up each answer and ask if there's anything else the user would like to know about COVID or the pandemic. And then we have our start of our information about the question that we're answering, and we have our documents here, and then the end of the information about that question. So, and here we're loading up that prompt template. We're putting in our documents as text and our variables as question. We're using the load summarization chain down here, and we're using stuff once again, and then we're storing the answer in a variable called answer. And this is just to format our output once again. So let's check this out. Okay, so now we got a much better and more rich and descriptive answer that used more of the research documents. So this looks much better to me. Now, whenever we're building these LLMs, it's not very satisfying to have this type of interface, especially when you're showing other people. So we're going to add a fancy UI to this, and we're going to use a library called Gradio to do that. So when we build LLMs, it's not very satisfying to just work in a notebook, especially when you're showing other people your work. So it's often very handy to build a nice little chat UI to show off your work to your coworkers and to your stakeholders. So let's use a library called Gradio to do that. So we're going to build a chatbot. This one's not going to have memory. It's going to be pretty straightforward, but it'll still work really, really well for us. So first, we're just going to import a couple libraries here that we will need for Gradio. And in the next section, we are going to use Gradio for our interface. So we're importing Gradio as GR, and we are creating our generate function. So this is basically the steps that we're doing when the user asks a question. We first pass that question to our similarity search, to our vector database, and we're going to get 10 documents back once again. And then we're just going to call our prompt chain here and use the prompt template that we had previously defined. So those are the only 2 lines of code that we need there. The next section is for the UI itself, and we're using this interface module here. It has a couple different parameters that we can tweak, so we can create a title and description and different types of buttons and inputs and outputs. I'll just run this code and actually just show you what it looks like. And the great thing about Gradio is that you can actually deploy this as an API and as a URL, and share it with your coworkers. So we'll do that and run it from our browser. All right, cool, right? So now we have a pretty cool interface for our chatbot. It says, ask a question about COVID-19, and the chatbot will answer using the latest research from 2023. And we also have a couple example questions that are pre-populated down here to make our life easier. So let's do the first one. What were the financial implications of COVID-19? And here's the answer that we get back. It's a nice little summary about how COVID affected the economy. It says that the stock markets lost $6 trillion in value over 6 days. And it talks about a couple different industries. Down here, it talks about tourism. It talks about the education sector. It talks about the entertainment industry as well. So that seems like a pretty good answer. Let's look at some other examples here. What are the long-term COVID symptoms? And once again, we get a really nice summary here in the interface talking about some of the different long-term symptoms, including fatigue and shortness of breath, cognitive impairment, and so on. Let's do one more question here, and let's do the one that we started with so we can A/B with ChatGPT. Let's do how many people died from COVID-19? And here you can see that you get a completely different answer here. As of March 10th, 2023, more than nearly 7 million deaths have been attributed to COVID-19 worldwide. So, if we go back to ChatGPT, very different answer, and we can see that we're obviously referencing the research documents that we had ingested into our vector database. So think about, how can you use this tool at a company or maybe even at a university? Say you're doing research and you have to read thousands of or hundreds of research documents, and this could be a great tool to find the information that you're looking for super fast. So I'm going to go back to our notebook here and show you a couple more things. So the chatbot that I showed you doesn't have memory. LLMs inherently don't have any memory, but that's something that we can add to them by simply storing our conversation history and then passing that back to the LLM. You can do that pretty easily using LangChain. So we're going to use the conversation buffer memory to do that and store our chat history. We'll run this piece of code here. And then we're going to use the conversational retrieval chain to pass that back to our LLM. So I haven't built out a fancy interface for this part, but I think you'll get the idea anyways. So we'll ask the question, how did COVID affect learning in children during the pandemic? And let's take a look at the answer. Okay, so we get our answer here. Now let's take a look at the memory here and the memory variables that we have saved. And you can see that we store the question that we answered, and we also store the AI message. So the response gets saved as well. And we can follow up on this now, right? So we can ask questions like, what subjects were impacted the most? According to the given information, learning deficits during COVID-19 pandemic were larger in maths than in reading. And let's follow up on that again. Let's just take a look at the memory variables. And you can see that we saved the first question there. How did COVID affect learning in children during the pandemic? And then what subjects were impacted the most? And we got both answers as well. Let's follow up once again and just ask why. And we got the following answer. According to the available research, learning progress in mathematics is more dependent on formal instruction than reading. And it goes on to explain why. So the point here is that we were able to add memory, and we can follow up and dig deeper into our questions. And you can build a simple UI for this as well if you want to. There's one more thing that I want to call out here. It's possible to store document metadata in your vector store and then fetch this metadata when retrieving the documents. And this is super helpful when citing documents and where the information is coming from. We didn't do that today, but I've included 2 links here that I'll post in the comment section below, so you can check that out if you want to find out how to do that yourself. So I hope you found this video really interesting and exciting. Think about, how would you build this in your industry? How would you kind of productize different parts of this flow to handle large volumes of documents and to improve on the system over time? And that's what a lot of people are trying to figure out right now. So hope you enjoyed this, hope you found it useful, and I'll see you next time.